Hello, welcome back. Today, let's try to solve another Leetcode problem, 410, split array largest sum. So for this problem, we need to check what is the descriptions about and what is the pattern for this problem. So basically, we are giving nums. So inside it is the numbers. We need to split the nums into two parts. We just need to check, return the minimized largest sum of the split. So what does that mean? This means we need to split the nums into two parts. For example, it is 7 to 5 and 10 to 8. So what is the largest sum? The largest sum, what is the largest sum? It means this 10 plus 8, it is the largest sum. That is why we need to return 18. So this is basically the minimax problem. We are giving an array and a number. We need to split it into k parts. For such problem, we should have the idea of a binary search because you can use DP, but DP is not the optimized solution. And also for DP, you cannot try to solve it every time. It really takes time. So this is why we need to recognize the pattern for the problem and then try to use the easiest way to solve the hard problem. Now let me explain why I can use a binary search. Because here, this is a nums array, and we also give a k. We need to split it into k parts. And we just need to guess a number to check if it is true. For this one, it is 18. But for us, we can use a binary search to guess the number. For example, if we guess a number of 18, we just need to loop through the nums array to check if we can split it into two parts optimizedly. What do I mean by optimizedly? I mean by greedy. If 7 plus 2 by 5, it is less than 18, so this is one part. And 10 plus 8, this is another part. So this is true, and the result is 18. This means our guess is right. But that is not yet the result. Maybe a smaller number. Let's guess another number, maybe 17. If 17 can be true, let's prepare a 17. So 7 plus 2 plus 5, this is one part. That is less than 17, this number. And then we have another number. 10 plus 8, it is 18, more than 17, because that is not possible. Now we have to prepare 10 as one part, 8 as another part. So in total, there are 3 parts. But we need to split it into 2 parts. This means the 17 is not possible. So what is our result? It must be 18. Because if the number is bigger, we're gonna try a smaller number to try if it is possible. If a number is smaller, if it is not possible, we're gonna try a big number. Finally, we're gonna return this number. Now, let's check the result first. The nums less is only 1000, and our nums I maximum is 10 to the power of 16. This means it's not a big number. So for the binary search, our time complexity is only 1000 times log 10 to the power of 6 times the length of the array. It's not a big number. So 10 to the power of 6 times 1000. Because the length of the array is 1000, and nums I is 10 to the power of 6. This means 1 times 10 to the power of 9. But log n we should use a log to this number. It is not a big number, and then we times the nums less. Basically it's a m times log n time complexity, and it's a very small number. This is why binary search is the best way to solve this problem. Now let me just finish my binary search pattern for the problem. If you saw my video for solving such kind of a problem, normally I would have a tag, and inside it is a threshold. So this is my template for solving such problem. And inside I will write a path first, because I'm not going to write the function yet. I just need to finish my main function. The main function is the binary search part. Now I'm going to use my patterns for binary search. It is L and R means left pointer and right pointer, and then I'm gonna use a result. So this means I'm going to return my result. So for the L pointer, let's check what should be the minimum value for our result. Because this k number, this k should be less than or equal to nums.less. This means if we have a nums.less of 5, for example, so what is the maximum part we can split? it is 5 because we only have 5 numbers. If we split one by one, we still have 5 numbers. So this means what is the maximum result? It is 10 because it is the maximum number after we split it into 5 parts. So 10 is our result. Yeah, as it is the maximum number. So this means the L pointer should be the max of nums. Now let's check the R pointer. What is the biggest number? Yeah, so if we don't split it, it means our nums is only one part. This means k equal to 1. It is the maximum. So what is the maximum? Only one part. What is the sum? The sum of the nums is the maximum. Yeah, so this is why. And we also need a result. For our result, it doesn't matter because our result will be finally updated to the optimized value 18. So the result, I will give a maximum of nums. You can also give a sum of nums or a 0. That is also okay. But for me, I will keep it safe, just to give it a L pointer to this maximum of nums. Now I'm going to use the binary search. So for L less than and equal to R, so this is basically the template. So the M should equal to L plus R minus L divided by 2. Now I'm going to use my check function. So I'm going to check this M because this value is just a number guessed. If I guess the number, for example, this number is 100. Yeah. Now I'm going to check if this 100 is possible to my result. What I mean by if I check a number, for example, 100, can I split the array into 2 parts? Yes. Why? Why not? I can split it into this part, it is less than 100, this part less than 100. I can even put it into one part because the sum of these numbers is always less than 100. Yeah, if I can split it into one part, why not I can split it into 2 parts? It means it is always true. Yeah, because if I split it into one part, I don't split, it is less than 100. Now I will split it into 2 parts, so the sum of them must be less than 100. So this is why the most important part for our check function, we have to use the descriptions to check how to write our check function and what is the conditions. This means if I guess number it is too big, I'm gonna have a result of my should equal to M, and then the pointer should be shifted. So this means my guess number may be too bigger, so the R pointer should be M minus 1. Else, the L pointer should be M plus 1. As I explained earlier, if our check function is wrong, maybe we guess number too small, maybe 10. As I explained earlier, maybe this is a 10. We can split into one part, second part, the third part, 4 parts. Yeah, if we use a 10, we split it into 4 parts. This means we can't split it into 2 parts. Yeah, because we already use the optimized solution, but we can split it into 4 parts. Now, can we split into 2 parts? No. If we split into 2 parts, it will always be bigger than our guess number 10. Yeah, so this means why I'm gonna use the L equal to M plus 1. Now I'm going to write the check function. Actually, the check function is easier than our analyze. If we analyzed how to write the check, how to shift the pointers for R and L, because sometimes according to the description of the question, so here will be the L pointer and here will be the R pointer, and the result will be in the different places. But basically the pattern is like that. Now I'm going to write the check function. So for the check function, I'm going to use a count. So this is also, for me, I will always use count. This count is as the number of k, how many parts I can split it. If I can split the part always smaller and less than this k, it means always my check is true. Because my final result, it will be, my count less than and equal to k. Now let me write the main function. So the count will start from 0 and the total is 0. This total means I'm going to accumulate these numbers. I'm going to check how many parts I can split it. Now I'm going to loop through the nums. So for n in nums, I'm going to accumulate the total. So the plus equal to n. Now I'm going to check. So if this total is more than, because if less than the threshold, I don't know yet. I have to check if this total is more than the threshold. Yeah, for example, this is 18. If my total, when I plus here, it is 9 and 14 and then 24 with this 10, it means that is not possible. So what I'm gonna do, I'm gonna calculate because I need to count by 1 and I need to set the total to this number n because this is another part. This is my first part, I've already split it. So this is my second part, I'm going to let the total equal to this number. Now I'm going to update the count by 1 plus 1 and the total should equal to this number n. Yeah. Now I'm going to go through the next num. So n equal to 8 and 10 plus 8 it is 18. So 18, is that 18 more than the threshold? Yeah, if we check the threshold is 18. No, it is not. This means my code will not plus 1. Yeah, so this code basically means how many cards do I need? So I only need to have 1 card. But finally, this code, for the meaning, when it compared with k, this k means how many parts, but here is how many cards. Yeah, 1 card means 2 parts. So this means why the code need to plus 1. This means how many parts do we have? If we have a count cut, it means we have a count plus 1 part. Yeah, this means we count from here, we have 2 parts. Yeah. Now, if this count plus 1 is less than and equal to k, this means this is always possible. Yeah, maybe this is a big number. Now I'm going to guess a smaller number. Yeah, because if I use a bigger number, it means possible. Why I try a smaller number to optimize it? Maybe it is also true. Yeah, for this one, I only need, if I guess a number maybe 100, I only need 1 card. Why not I guess a smaller number to make it two cards? Because the k is used to optimize my solution. Yeah, so this is why here I need to return count plus 1 less than or equal to k. Now let me run it to check if it really works. So here, let me copy the threshold. Here is a typo. Yeah. Now let me submit it, and after that, I'm gonna analyze the time complexity again because for such kind of problem, this has already been the optimized solution. Yeah. Now we just need to analyze the time complexity. So for the nums I, it is 10 to the power of 6, and the nums less is 10 to the power of 3 because 1000. And then this 1000 times 10 to the power of 6, it is 10 to the power of 9. But for this number, it is our binary search. We're going to use a log n. So log 10 to the power of 9, basically that is 30 or 40. That's a smaller number. And then we need to do time the nums.less, it is 1000. So finally, we only need like 30 times 1000 calculations. So there are only 30,000 calculations. That is why the binary search is so fast. Thank you for watching. If you think this is helpful, please like and subscribe. I will upload more Leetcode problems like this. See you next time.